Alright, NET-200. We are in week 12. Alright, so what we did, we we looked at everybody getting a router. And so we had everybody a router or a multi-layered switch. And we had them look at the configs, look at the interfaces, look at the routing table, and so forth. And these were connected. And then we put some IP addresses out there, and we were actually able to ping and so forth between them. Here's a little bit of the bigger picture. So we had multi-layered switch. They're all connected in these sections. You know, all look pretty similar. And we talked about show IP route, interface brief, show run, and then we pinged multiple places to see the communication. We pinged these interfaces. We didn't put on any workstations on them. Okay? And then this part right here, we started talking about if, let's see, you had one network here, and you had a bunch of switches and 500 computers, every time they did an address resolution, an ARP, to match up an IP with a MAC address, a broadcast would go out to all those. In fact, off of a router, every port is a broadcast domain. Okay, so what you could do is you could take and split this up. You could subnet your network and put some of them on a network here, some of them here, and some of them down here. You could divide it up by location. I think NIACC does that in terms of certain areas of buildings are on a certain network, so you don't have too many computers on the same network. Or you could do it by units or different groupings within your company. Let's say this one here is research and development. See, and then we could actually have an access list that restricts who can get in and out of there. So you could actually take a network and make it more secure. So we have these reasons for subnetting. And at least understanding the concept of subnetting. So we'll keep moving here. And then here's a look at the rest of the picture. We had, I was in this computer and we took a look at routes and connected routes and static routes. How we have a default route will get us out. This router has routes going into each of these networks. Okay, but to get up here, we could use a default route, and then we had the students actually from their routers, they were able to ping down to another router, and that information was able to come back because of our network. And then they also could go out to the internet. We didn't do that, but we could all the way out. Here's the rest of campus, so when it comes back in, the router makes a decision, does it belong on this part of campus or this way, based on the IP. And we'll look more at that. Alright, then we took this lab and we adjusted it. The students each got a router and they only configured a router. We did not add anything to it yet. So they just configured the router, and we wanted to put on there, we have 4 networks. See, each of these would be a network. And so what we wanted them to do is to pick an address from the subnets that we created. We created them over here. So we took an address, we took 192.168, I believe 10.0/24, and we subnet that into networks. 8 networks actually that can each hold 30 hosts. Okay? And then the students took from those networks and assigned them to these interfaces. Alright. So, to finish up with here, almost finish up, we'll take a look at the subnetting here. So we took this address and we looked at the bits we can manipulate. This you can't do anything with in our situation. We have this 24. And so then these we didn't change, but we took these 8 bits right here, took those 8 bits, and we determined that if we divide them here, so we'd have 3 bits here, okay, so we divided it here, and then we'd have these 3 bits, and that would give us, those 3 bits would give us a combination of, if we wrote them all out, 8 networks. 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 0, 0, 1, 1, then it'd be 1, 0, 0, and so forth. So this part was going to be our network, and if you're looking up here, that's why we added 3 bits on to the prefix, because now our networks are from here over instead of from here over at 24. And we have these bits left for host. So we took the first one, 0, 0, 0, we wrote it out, and it's a /27. Then we took the next one, which was this one, and that gave us this one. This one right here, gives us the 32 right there. One group of 32. And so then the next one, 64, that's actually this one. That one, 64, 64. And so we continued on. And I think we just listed 5 of them. And then to figure out what addresses would work, start here, like a 1 here, that's this one, and then we can go all the way up to where we have a 0 and all these 1s. And that actually would give us 30. Now, you can't use all 0s and you can't use all 1s. So that's how we got this combination. Then we did a similar thing for each of these. And you'll notice there's a little bit of a pattern, right? You're going to see that as you look at addresses in the next network. So we had these 4 made, and the students then assigned those. So they took these and they assigned them to networks over here. I don't know exactly which network they assigned them to. They could assign them to the networks. So there's 4, and we actually have 1, 2, 3, 4 more left, and we didn't figure them out here yet. So we could add 4 more networks. And each network has 30 addresses available. And that's it.